Okay, so go back to the question 25. Start back. So look at your function here. X greater than 2. X greater than 2, quadratic is taking the right hand side part only. So given your function gx is ln, the condition of ln is x greater than 0, find inverse and g inverse. After finding your f inverse and g inverse, take their domains of this inverse function. So we have two parts to see. First, we get to our inverse function first. F inverse x equals to y. So inverse the function, domain and range as change. Fy equals to x, substitute your y into your quadratic function here, plus 1. So as long as your quadratic function is already in completing the square form, so everything will be easier for us. If your quadratic is not in completing the square form, then we have to do it completing the square first. So from here, we find out our y. We express out our y in order to find our f inverse. So move your 1 become negative 1. So move your square root, it become positive negative. Move your square become square root, become positive negative. And y become positive negative square root x minus 1 plus 2. So here we have two answers. Positive square root x minus 1 plus 2. Another answer, negative square root x minus 1 plus 2. So look back on our condition here. Our quadratic, this part, they are taking the right hand side part because x greater than 2. Right hand side part means our y value will be taking the positive answer because most of the things when we going to right hand side, it is positive. We're getting positive. So since x is greater than 2, my range here will become positive square root x minus 1 plus 2. So once we get our y, it will be our f inverse. Continue, find the g inverse. Okay, so same concept going, where g inverse x equals to y. So gy equals to x. Substitute y into the function g. Ln y plus 1 equals to x. Find out our y. So we are going to unlock here. When you unlock, the base e will go to the opposite, the x become power. So move the 1 become minus 1. So therefore, we get our g inverse. Here will be ex minus 1. So that will be our first part of the questions. Second part, state the domain and range for each of the inverse function. So for domain of f inverse, alright, so for domain of f inverse, we have to refer to the range of function. Okay, to the range of the function. For the range of the f inverse, we have to refer to the domain of the function. So we can see the range of the function. So I can do the range of the f inverse first because range f inverse equals to the domain here. Our domain here is special case because they got condition here. They said 2 to infinity. So 2 is not included. Greater than 2. So 2 to infinity. So that will be our range of f inverse by referring to the domain. So when we want to find our domain of f inverse, we have to do the range for this. How we do the range for this? This quadratic in range concept, it is a special case. So how we do our range? We close up, we close this part. We close the range, we close the characteristic of quadratic, we can see the value 1. And then this quadratic is a positive quadratic. So means that the range of the function will be 1 to infinity. So this is how we find our domain and range inverse function based on the original function. Okay, so for the domain G inverse, I will refer to the range for this, range for the G. So range is not a special case, right? So it will become negative infinity to infinity. But you can see, so this is how we see the things. When you see the range of the G inverse, you can see our range here, our domain here start from 0. Our domain here start from 0. So means this function is in condition. Okay, so I will do the domain first, which is range for G inverse first. Range for G inverse, I refer to the domain here. So supposedly domain here, I have to calculate x plus 1 greater than 0, x greater than negative 1. But the condition give us said that they don't want x start greater than negative 1, they want the x starts straightforward from 0. So I have to follow the condition from the question. So the domain of the gx is 0 to infinity. Okay, I repeat. Okay, so asalnya kalau log kita perlu kira, memang domain dia kena kira dia apa yang log bawa mesti besar daripada kosong. So untuk log berfungsi, x dia mesti greater than negative 1. Tetapi soalan ni dia dah tambah addition condition dekat tepi dah. Dia bukan nak start dengan negative 1, dia nak start lagi at once, iaitu x kosong, lebih dari kosong. So they are not taking the whole graph already. So they are taking part of the graph only. So original, if x greater than negative 1 means our graphing here, original is negative 1 is our asymptote. So our log will be going like this. With the asymptote kaki di bawah. We're going like this. This is our original ln x plus 1. So because of the condition, you can see, because of the condition here, they said they want to start x greater than 0. Means this part, start from 0. This part, all this part, now is not in the concern already. Not in the consider already. We're not concerned about that. We have to follow the instruction from the question where they ask us start from x, start from 0. So my asymptote part and the kaki-kaki kat bawah ni semua sudah jadi tak terlibat. So domain saya akan jadi 0 to infinity. So how about our range now? Originally, our range will be start from negative infinity to infinity because this log dia ada kaki sebenarnya daripada negative infinity ke infinity. Tetapi bila sebab soalan tu dia tak potong dia nak sebahagian saja, so sebahagian daripada graf saya sudah hilang. Sudah tidak terlibat. It's not involving in the questions already. So the part that involving in the question only is x greater than 0. So when we see our graph here, when you got condition, so we have to refer to our graph here, which part is the remaining part. So the remaining part will be x greater than 0, which is this part. So domain 0 to infinity, because domain is talking about, domain of the gx is talking about x, which is same to range of inverse. Then when you want to find the domain of G inverse, I will going to find the range. Find the range for this G. Look at the Y. So the Y, the most minimum value here is 0. So until infinity, because the graph still shooting up non-stop. So 0 to infinity, not included. Not included because the first point 0 here also not included. So supposedly here is an empty circle and the graph shoot up. So this is how we get our domain and range. Okay, so let me put the marks here. Concept of calculating our inverse and select to the correct, because this function originally is not one-to-one, but because of the condition of the question, it become one part of the graph only, it become one-to-one. So select the correct part and then get to the inverse function. And then this is the domain and range. So for ln, the inverse function will be more easier, but the domain and range is a tricky part, because they already cut off some part of the question to make it to ask us to find the domain and range. So for part B, they ask us to obtain a composite function. So we calculate out what is our composite function here. We substitute our function one by one. G of x. So equals to, substitute our fx here. Our fx is x minus 2 squared plus 1. Okay, so substitute the whole things into our gx, into the x part, which is ln, and then x minus 2 squared plus 1 plus 1. So you can see, don't miss out, don't confuse. I will going to substitute this into here. So it will give us the result plus 1. This is the x part. Substitute this into the x part. So this is my result. Alright, so then we simplify. We simplify this. It will become ln in the bracket x minus 2 squared plus 2. So we have to put our bracket. Why? Because this bracket means that log bring this thing. The log is bringing these terms together. If we missing this bracket, you can see if we missing this bracket, the things will be different already. It will make us misunderstanding where log only bringing this x minus 2 squared. Okay, so supposedly they are bringing it together, bring this together. So after we get our composite g of x, evaluate. So we put in our value gf2. So substitute our value of 2 into the composite function here, which is ln 2 minus 2, 0, plus 2. So it will be equal to ln 2. So make sure we give us the answer in decimal. Finish up the calculation. At least 3 significant figure. So here already 3 significant figure, 1, 2, 3. Alright, so this is how we do our composite. Substitute our gx and get to the answer. Substitute our value to evaluate our composite function.